15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the Space Nuts podcast. My name's Andrew Dunkley, your host, and with me, as always, my good friend, Professor Fred Watson. Hello, Fred.
Hey, Andrew. How are you doing?
I'm well, and you?
I'm very well, thank you. Managed to catch up with my sleep since the last time we spoke.
In fact, you just woke up. Now, today we're going to be talking about women in space. A couple of weeks ago, we talked about that attempt to do a dual female spacewalk, but there was an issue with a spacesuit. And I did mention in passing that I had heard somewhere along the line that women are better suited to space travel than men. And now it appears that that is actually the case. So we're going to look into that. There's also a question of the lack of observed supernovae in our observations of space around us, and why would that be? And a question from Tim in Adelaide about lone stars. Do they exist? That is a great question we'll get into. And I've heard a little whisper, Fred, of a book that's gone to a publisher. Not named Parallax, by the way. See how I did that?
Yeah, I thought that was very good. Yeah, Parallax. I actually, in the book, my book, I said, check out Andrew Dunkley's book.
Oh, yes, so that was nice.
So this book, yes, it's gone to the publisher a week or so ago. It's a book of really the latest and greatest in the world of space and astronomy, the stuff we talk about, in a little bit more detail than you might normally get, but not technical. The idea is to make it accessible to people reading a book on a beach or a plane or wherever, who don't have any specialist knowledge or interest in astronomy. It's just to be informative. But it doesn't, it's not a complete account of the universe. It's some of the things that are really attracting attention at the moment. And the final chapter really addresses the issue of intelligent life beyond the Earth. And so I kicked off the chapter by a little bit about the fact that we love the idea of intelligent aliens, and these are they're the darlings of the science fiction movie world. But then passed over to you because I said you might be aware of Space Nuts, and on the Space Nuts team, I am not the one who knows all about science fiction. It is that other science fiction expert who's also a published author, Andrew Dunkley.
Oh, that's lovely, Fred.
Yeah, it's just to let people know. I said look him up, so they'll check you out.
Oh, thank you.
Unless the publishers delete that paragraph, of course.
They could do that. That's why I self-edit, which will be evident in some of the grammatical and spelling errors of Parallax. But what's the title of the book, Fred?
Well, that's a really good question.
That's a great title.
I've never thought of that one. I've had pretty well every other. So it started off as Wednesday's Universe for reasons that needn't bother us now. Then they didn't like Wednesday's Universe, so its working title was Cosmic Addiction. Mm-hmm. But then they decided they didn't like that. So at the moment, it's Space Unearthed.
Oh, okay. Well, that sounds fine.
Yeah,
it's kind of a play on words because we live on Earth. So
indeed, we do. Marnie's the great one for choosing good titles. Star Craving Mad was her idea.
Oh, nice.
Yeah,
I like that. All right. Watch out for Space Unearthed coming soon.
Or whatever it is. Yeah, October.
Or whatever it is. Once we know the title proper, we'll let you know.
Yeah, I'll let you know whether you're still in it as well.
Yeah, that'd be good. Now, women are better than men in space. They are on Earth too, apparently. But yes, this is something I'm sure I read or heard about somewhere. But now it looks like this is official.
Yes, although
careful.
They're not that much better. They're a bit better.
You crossed the line, Fred.
No, because that's great for space flight planners. Because if you can point to advantages on one side of the other or the other of a gender distribution, then spaceflight planners might lean one way or the other, and that would become, it would be inequitous. It would be unequal. So what the outcome of this research is that yes, there are certain things that women actually survive better than men in space, but the difference is not big enough to make it worthwhile imposing that as a selection. So you make it as gender equal as you can. Having said that, one of the problems with this study, Andrew, is that of the 550 people who have gone into space, by far the majority of them are men.
Yeah.
In fact, it's actually pitiful. The number, the number who are women, it's not much more than 10%.
That's because they can't get through the glass ceiling.
63 women, exactly. That's right. It's all about it's all about all the things that we read about all the time about the things that impede the progress of women in business and in life all the time, scientific research, all the rest of it, the kind of thing that we've got to get rid of.
Yes, I totally agree with you. I totally agree with you. And yet in our day-to-day lives, I still witness and experience that certain things are done by women that aren't done by men, and you wonder why. But if I can just go aside for a little moment, I remember seeing a documentary not too long ago where they did a bit of an experiment with young male and female monkeys. And they just threw out all these toys, some designed for boys and some designed for girls, to see what the monkeys would do. And initially, they all played with everything, but finally, and this is the most intriguing part, the boys gravitated to the boys' toys and the girls gravitated to the girls' toys, which just blew my mind. It seems to be something that's ingrained into our existence, and maybe that's the problem. Maybe it's just hardwired. Well, yes, and we just have the consciousness to realise it and do something about it. But it's not as easy as just doing it. We've got to retrain our thinking, retrain our minds.
Yes, that's right. I think that's a really good way to put it. Actually, we've got to wake up to things that are going on that do predispose us to this kind of sexism, which is what it is. So, just coming back to this particular study or a set of studies actually of the possible gender differences between men and women in orbit. It's you can break it down into all kinds of different aspects, and there's a really rather nice piece on, actually it's the Australian Broadcasting Corporation's article about this. They've outlined 1, 2, 3, 4, 5, 6 different areas of human physiology and compared men and women in those areas. So it starts with cardiovascular. And we've talked about this before, the increased pressure in the eyes of astronauts.
Yes, that's right.
And it's actually males who are predisposed towards that. They suffer more than females do when you do it on a per capita or a per head basis. On the other hand, women seem to be, there's this curious thing, is women are more likely to faint when they stand up once they've returned to Earth, which is, another peculiarity of the cardiovascular system. I think the next one is one of the key, it is one of the reasons why this result is being badged as women are better in space than men. And I'm just going to read it from the ABC website. On Earth, women mount a more potent immune response, meaning they're more resistant to infection. That's the positive side. But it turns out on the negative side that women are more prone to radiation-induced cancers. Of course, that's one of the hazards of long-distance spaceflight. And so these things all mount up. There's a whole lot more. I won't really go into the detail, but there's weight loss and things of that sort. It turns out that actually women make up that weight loss more quickly than men do. That's, I think, one of the reasons, again, why this is being touted as advantageous to women. But it's only very, very slightly. And of course, you're dealing all the time with small number statistics here because of that fraction that I mentioned before. Only 63 women have flown in space.
Yeah. And what's really interesting is we were on the right track early on. Yuri Gagarin was first in 1961, but then in 1963, a factory worker named Valentina Tereshkova, who was also an amateur skydiver, did 48 orbits of the Earth, which, and then it was 20 years before the next woman went into space.
Yes, who was also Russian.
Yes. So, I mean, the Russians were probably ahead of the game in many ways, although that 20-year gap is a yawning gap. But they showed straight up that they were capable.
Wouldn't it be wonderful if we could, in this 50th anniversary year of the Apollo landings, if we could look back and say, well, the crew of Apollo 14, all women, something like that. But it wasn't
Fred,
like that.
Just somebody whispering in my ear said, why don't we just send all the women to the moon on the 50th? Sorry.
Yeah,
should never have gone there. That was bad.
Anyway, moving on, Andrew.
I'll get shot for that
Interesting
one.
Story, though. Interesting story. It's a bit like
really good.
Sorry, go on.
No, I'm just saying it's really good that the point I made a couple of weeks ago proved to be slightly right.
Yes, that's right. Indeed.
All right. You're listening to Space Nuts. Andrew Dunkley here for the time being with Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we're going to talk about an interesting problem, I suppose you'd call it, and that is that we're missing things in space. One of those things is supernovae. We have seen them in the past, but it seems in recent times we haven't, and it looks like we missed one, which is very interesting because they're so very easy to see, apparently. Now, what prompted this little tale?
Yeah, so it's a friend of mine who's also a Space Nuts listener, Peter Verweyen. We used to work alongside one another at Siding Spring in New South Wales, where the Siding Spring Observatory has Australia's biggest array of visible light telescopes. So Peter was a technician on one of those telescopes, a senior technician, now lives in Sydney. But he raised something that I hadn't really thought about before, but it's a very good point. And he directed me to a NASA report on, as you say, one that we missed, a supernova that we missed. So what are supernovae? They are stars that explode at the end of their lives. They're very dramatic and destructive events, sometimes leave a black hole behind. The term actually comes from an old term, which was nova. And nova just means new. It was a nova stella, in fact, new star. We still... I suppose it was probably in the 20th century that we distinguished between what are now called supernovae. So a supernova rather than just an ordinary nova. A nova is a star that undergoes a very dramatic outburst, but it doesn't blow itself to pieces. So it's not a grand finale. Whereas a supernova is. It's a star doing all kinds of horrible things at the end of its life. And they're very, very bright. When you see them in distant galaxies, they often outshine the rest of the whole galaxy put together.
Wow.
If you've got 100 billion stars in a galaxy and one supernova goes off, it's brighter than the rest of them for a short period, a matter of days or weeks, something like that. Now, the naked eye supernovae that have come in within the last 400 years or so, there was the one that was observed by the Danish astronomer Tycho Brahe, he would have called himself, in 1572, I think it was. That supernova it's usually called Tycho's supernova, bright enough to see in daylight. It's what steered him towards a career in astronomy. Then there was another one in 1604 that was observed by Kepler, another naked eye one. And the next one wasn't until 1987. And it wasn't in our own galaxy. That is in the Large Magellanic Cloud, which is a galaxy quite close to ours, about 160,000 light years away. It's
a galaxy not so far away.
Not so far away. That's right. That's the one. You've got it. It's the nearest big irregular galaxy, or how can I put it? The nearest big dwarf galaxy, if that's not a contradiction in terms. That had a supernova in it. 1987 is a memorable year for astronomers here in the Southern Hemisphere because everybody kind of stopped doing what they were doing and got straight into becoming supernova experts. And we're actually still observing the remnants of that. There's some wonderful images come from the Hubble telescope with the debris from that supernova explosion. So that's, there's a gap of 400 years there between supernovae, and one of them wasn't even in our own galaxy. So you've got a very long period of no supernova explosions, whereas the theory says that there should be roughly one every 100 years in a particular galaxy. So
that doesn't mean to say that we've missed any, because 400 years versus every 100 years, I mean, averages vary accordingly.
Yeah, it says all it says is we're overdue for one.
However,
that's right. But yes, this is where it gets interesting because, speculating as to why we might have missed them brought about from the woodwork. And as I said, Peter actually drew my attention to this. And I think it was one of his wife's students, who's an astronomy student, came up with this little news item of a supernova remnant. So we can recognize remnants of supernovae. They've got strong characteristics, twisted magnetic fields and, clouds of very excited gas. Those remnants tell you that there has been a supernova. For example, just digressing for a minute, there was a supernova in, I think it was 1054, which was just before the Battle of Hastings. That supernova was recorded by the Chinese, and we can still see its remnants, and you can work back from the remnant and say, yes, that's when it went off. So supernova remnants are interesting, but normally the supernova that caused them was pretty obvious, especially if it was a recent one. And so the paper that Peter and his friends have sort of directed me to is about a discovery by an X-ray telescope. It's called Chandra. It's in orbit around the Earth. It is one of NASA's great observatories, of which Hubble was the first. And Chandra reported some years ago a supernova remnant within our own galaxy, which all the signs are exploded as recently as 140 years ago. And nobody saw it.
Oh, I know I didn't.
It outshone the galaxy. Well, you and I were around at that time.
Well, the thing is, 140 years ago, we were observing.
Absolutely, with pretty damn good telescopes as well. These were the 19th century refracting telescopes and some reflecting telescopes. In fact, there was one here in Australia at that time, a large reflecting telescope called the Great Melbourne Telescope that had been going for 10 years 140 years ago. So we missed it. It basically did not, show up. And the answer is why.
Oh, the question is why.
The question, that's right.
Yes, I want to know the answer.
I think I'm still jet lagged, Andrew. I'm getting my questions and answers mixed up. The answer is why, and the question is that it probably was heavily obscured by dust. And what that tells you, I mean, it gives you a really good illustration of how dusty some parts of our galaxy are. This dust is it's almost like interstellar smoke. It's very common throughout, particularly the disk of the galaxy. And it can, because there's so much of it, even though it's very, very fine dust and it's pretty thinly distributed, if you're looking through 3 or 4 light years of this stuff, you can't see anything. And it has what we in the trade call a very short optical depth, you can't really see through it very far. So it seems likely that what the Chandra X-ray telescope observed was a supernova that went off, did all its brightnesses and things like that, but nobody noticed it because it was in the middle of a large cloud of dust and we didn't see it.
Okay, now here's the question. That was 140 years ago. If that same event happened today, would we still miss it?
We wouldn't, actually, because we now have, things like X-ray telescopes that would certainly detect it. Even if it was in a dusty region where the visible light pulse from the supernova didn't reach us, we'd have X-rays coming from it. We'd have neutrinos, these subatomic particles, which are dished out copiously in supernova explosions and travel effectively at the speed of light. All of those things we now have detectors for, so we can actually see them, whereas you couldn't 140 years ago. Yes, we would definitely know about it.
Okay.
And in fact, if it was near enough, the neutrinos would not do us any good, really.
Oh, good to know. Well, we'll just put that one aside for a moment. The other astronomical thing that happened in 1987 is I married Judy.
Well, there you go.
That was a wonderful event.
It's a supernova event of its own kind.
Yes, still shining brightly.
Very good.
And that's about all you can say, really.
Congratulations.
She gets a bit embarrassed when I talk about her, so I thought I'd better stop. I was going to say something else. You're listening to Space Nuts with Andrew Dunkley and, of course, Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, Fred, to a question from our vast audience. I think this is our only listener in Adelaide, South Australia. Hello, Tim. And he writes and says, we're always talking about the stars in our galaxy, the Milky Way, and all the other galaxies that we see in the universe. However, he wants to know, are there any lone stars between the galaxies? And if so, how common are they? Why are they not part of a galaxy themselves? If this is the case, would there be exoplanets orbiting those lone stars? Now, I can answer your question straight up, Tim. I know of one lone star. It's called Texas. But that's the only one I'm aware of. But I'm sure it's like we've talked about rogue planets, Fred, and the fact that they're sort of floating around by themselves out there. I suppose there would have to be rogue stars as well.
There are. That's right. And Tim's right on the money. There are indeed these lone stars. They're not easy to observe because, if you're looking at kind of galactic distances, like the nearest big galaxy, which is the Andromeda Galaxy, M31, at that sort of distance, 2.5 million light years, it's pretty difficult to pick up a single star. Although some stars are bright enough for us to do that, and they certainly have been observed on the fringes of M31. So if you think of our own galaxy, it's got the disk of the galaxy with these lovely spiral arms. That's where the density of stars is highest. But we also have this spherical halo, which is also stars, as well as we know it's got dark matter in it now as well. But there are stars there too. And on the fringes of the halo are stars which are only just gravitationally bound to our own galaxy. They're sitting on the edge of it, and it wouldn't take much of an interaction between two stars to give a gravitational push to one that would push it out of the galaxy altogether. And so that's one way that stars can leave galaxies. A more common one is it's the same process, but in a more dense region of a galaxy. So you can find stars which are moving at high velocity. And in fact, this was connected with some work that I did a few years ago with many colleagues. I was not leading this work, but I was certainly a big part in it. It was Project manager, in fact, for a catalogue of star velocities. This is the RAVE catalogue, RAVE being the radial velocity experiment. The radial velocity is the line of sight velocity of a star. And one of the first things we did when we started getting large quantities of data was look for stars which are on a trajectory that will take them out of the galaxy. And so what you are looking for is what we call high velocity stars. And we found quite a lot. I think we found 20 or 30 of these things. So these are stars that are within our own galaxy, but they're not going to be forever because their trajectory is taking them right out. In other words, their speed exceeds the escape velocity of the galaxy itself.
Wow.
So those are going to be lone stars. They'll wind up wandering in intergalactic space. So there are objects like that. Why did they get these very high velocities? Probably because of some sort of a very close gravitational encounter with another object. For example, a small star might have strayed too close to a big star. The big star gives it a gravitational kick. The next thing the small star knows is that it's hurling out of the galaxy
so
at 300-400 kilometers per second.
The slingshot effect of a spacecraft.
Yeah, so that's right. Exactly. Yeah. It's almost like the gravitational slingshot. And I think there's probably often the thing that provides the slingshot might well be not so much a massive star as a black hole.
Yeah.
And of course, coming very close to a black hole gives you a really big kick in the pants, and away it goes out of the galaxy. One other. Okay, so just turning to the last bit of Tim's question: would there be exoplanets orbiting those lone stars? Yes, possibly. We know that all stars on average have at least one planet around them. So that might well be the case for these. It is possible that if they've undergone some sort of serious gravitational disruption to get them pushed into an orbit that takes them out of the galaxy, that could well have stripped off the planets as well. So you might end up with a clutch of these rogue planets that you were just talking about a minute ago. But it is possible that they would still have their exoplanets with them.
So we don't really want our star bumped out of the galaxy because that could, be bad for us.
Yeah, it could be, because we might end up a rogue planet. There's plenty of rogues on the planet, but
yes,
to be a rogue planet is not what you want.
Quite a few.
Just one footnote to this, Andrew, is that one of my colleagues who mentioned recently, actually, I think I mentioned him last week, his name's Ken Freeman. He was one of the first people to notice that galaxies had a peculiar rotation curve, which we now interpret as being evidence of dark matter. But one of the other projects that Ken has worked on, and I kind of know about this because while I wasn't part of the project, I was his telescope support in some of this work. This is 20 years ago or so. He was looking for what are called planetary nebulae in intergalactic space. Planetary nebulae are a bit of a misnomer. They're gas clouds, but they're very small and compact and spherical. Generally, they often have funny shapes. And it was William Herschel, actually, who recognized these things and said they look like planets, but they're not. They're nebulae. They're clouds of gas. So it's called them planetary nebulae, which has fooled everybody ever since because they're nothing to do with planets. It's basically the cloud of gas that's expelled by a star reaching the end of its life, the sort of white dwarf phase of the star. Our sun will go through this period in 3 or 4 billion years. It will become a planetary nebula. So planetary nebulae are relatively easy to find, even at great distances. And Ken's study was about intergalactic planetary nebulae. So these are the decaying remnants, the corpses almost of stars that were intergalactic stars. So there's evidence from that source as well that these things do exist.
Okay. Now, you say some of these are moving at high speed, they'll leave our galaxy. Given the long life of a star, are they likely to end up in another galaxy, or is it just too vast a distance compared to their velocity for them to end up anywhere?
Yeah. Good question. I don't think it's out of the question to imagine that we might transfer stars from our galaxy to the Andromeda galaxy. I'd have to work out the numbers, but at first thought, that seems, likely. I mean, some stars last for 10 billion years.
Yeah.
Our sun's that kind of group. It's a relatively small star, a dwarf star, so it's got well-behaved atmosphere and things like that. It's not going to flare up and go off pop when it's only a few million years old. It's already 4.5 billion years old, so it's doing quite well. But there are some stars that probably the oldest star known is almost the age of the universe. It's very, very close to the beginning. So these long-lived stars would last long enough to make the journey from one galaxy to another. The problem with them is that they're dim. And so, at the distance of the Andromeda galaxy, you'd never find them.
So we can just assume for the moment that that's a possibility.
The case.
Yeah. All right. Thank you, Tim, for your wonderful question, and thanks for being one of the space nuts. He says he's a fellow space nut, and yes, there are more than two. Well, with you, Tim, there are now three. So there you have it. And thank you, as always, Fred. It's a great pleasure.
Yeah, it's a pleasure to talk as well, Andrew. Always good to talk about this stuff, and I look forward to next time.
And good luck with the book. Can't wait to find out what it's going to be called and get a hold of it when it's out there.
Yeah.
And we'll catch you next time. Fred Watson, astronomer at large, and from me, Andrew Dunkley, thank you as always. Keep those cards and letters rolling in, even emails. We take those. And we'll catch you next time on another edition of, episode 150.
Da-da-da.
We better start planning.
Yeah, we had, haven't we? Got to have a party for that.
What are we going to do?
Yeah, we answer some questions. How's that?
That sounds like a good idea. So if you have got, here's a pitch. If you've got a special episode 150 question that you want us to answer, send it in within the next week, and we'll see if we can knock a few of those off, because if there's been something bugging you or something special that you'd really like to get nailed down, we'll try and tackle it without notice, a question without notice. So you can do that via our website, bitesz.com, bitesz.com, or through our Facebook page. And until next time, it's goodbye from him and goodbye from me.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from bitesz.com.